Okay, let's talk about correlation coefficient. So let's see. The scattered plot below shows the fuel efficiency of 10 popular car types and the engine size. So the way we understand scattered plot, that if I pick a point, that point tells me that the engine size is 1 liter, and therefore the fuel efficiency, let's say, will be almost 18 kilometers per liter. So that's how we understand. Okay, let's see what we need to do. And always when you see scattered plot, it will be about correlation coefficient. So now, before even we go into that, so let's say you are there and you come across a term that you're not really sure what that means. You don't remember what that means. So in that type of situation, I'm always saying, try to break down the English, just focus on the English meaning of the word. So when we are saying correlation, it means something about a relation, about a relationship, isn't it? So that's what that word is about. Coefficient means something about efficiency. So we are talking about relationship and efficiency of that relationship. And that's kind of what it is. Now, even before we go into detailing this question, we need a little bit of knowledge. So we can have, when it comes to the scattered plot, we can have five really types of situation. So let's just get a little bit. So let's say I have dots, and then I have more dots, and then I have one like that. Okay, so the idea is that actually my first one is not very good. My apologies. That didn't happen very well. Oh, again, it's changed. So let's do the dots. Okay. Now, so the idea is that when I'm looking at those dots, I'm thinking, okay, I can say kind of that they are going in this direction, isn't it? Now here, I am most certain that they are going in this direction. Then if I'm looking here, again, I can say they are kind of going in this direction, but here I am pretty certain they go in this direction. And here, no direction. They're all over the shop. Okay, so what does that mean? When they are going up, like a slope, that means that we are talking about value +1. If they are going down, the same like the slope, we are talking about value -1. When they are going nowhere, we are talking about value 0. So our correlation coefficient will be going from +1 to 0 to -1. Okay, that's how. And if it is close, like this one here will be closer to 1, this one will be more further away from 1. The same for the minus. And this type of correlation will be strong, and this one will be weak. That's basically what it is. So here we have, there is a correlation between engine size and fuel efficiency. And we can actually see that, isn't it? We kind of can see that this line kind of goes down like that. So straight away, we are thinking, okay, it goes down, is going to be about -1. And it is pretty, maybe not strong 100%, but it's pretty strong, isn't it? So based on the diagram above, pick a description from the list below that the best describes the correlation between engine size and fuel efficiency. Explain your choice is in the relation to fuel efficiency and engine size. So like what we said, it's going down, therefore it's negative, and is this pretty strong negative. So what is the explanation that we can talk about in relation to fuel efficiency and engine size? What can we conclude? That the bigger the size of an engine, the fuel efficiency goes down, isn't it? That's the kind of relationship we can describe. We can see that those engines that have the bigger size, therefore the efficiency, they are not as efficient. Yeah, if I am comparing this one that has almost 18 but only 1 liter, this one here that has 4 liters, efficiency is only about, let's say, 8. So pretty much it goes down. And that's actually it is in life. Now, the next part, Tom says that the correlation coefficient for two sets of data is 5. We know he is not correct. Explain why this cannot be correct. Well, the simple reason is because correlation coefficient is between values -1 and +1. So he cannot be correct because we don't have 5 as a correlation coefficient.